Okay, let's continue. There was a technical problem. Sorry about that. So I don't know, there was a problem with the screen sharing. But let's continue with the definition of the linearity. So linear differential equations. So we have an ordinary differential equation, and we want, so these coefficients, you see these coefficients, they depend only on x. So here, if you see, we have the nth derivative. Sometimes we write it like that, y to the power n plus a1x. So this means that, so this means that this is the n minus 1 derivative. So we keep taking the derivative. Y prime, you see we have a and x, y is equal to bx. So we have the coefficients are, they depend only on x. So okay, and we want this to be non-zero, because if this is the zero, if this is zero, this is the coefficient of the highest derivative. If a 0x is 0, then we would have the order would be n minus 1, right? But we define the order to be n, so that is why we don't want it to be 0. So that is why it is non-zero. But let me give examples that it will be clear. It will be clear. Okay, let's look at this one. Okay, we have third derivative plus cosine x d square y dx square plus xy sine x square. So this is a linear differential equation. There is no problem with that one. So we look at all the coefficients. Okay, we look at all the coefficients. Okay, these are all, and so this is bx also. This is a0x, a1x. You see they depend only on x. And you need to be careful. So this is y, so y prime y, so that is y. This is okay, so this is okay. So this is a linear differential equation, but what is the order? So this is a linear differential equation. What is the order? Order of the highest derivative. What is the highest derivative? It is a third order, right? So we take the third derivative. Third order linear ordinary differential equation. So this is such an example. Okay, let me give other examples, but before that, let me define what is a nonlinear differential equation. It is easy, very easy. If the ordinary differential equation is not linear, then it is called a nonlinear differential equation. So if an ordinary differential equation is not linear, then it is called nonlinear differential equation. Okay, let's continue the examples. Okay, let's continue examples, giving examples. So let's look at this one, dx cubed d6 So we take the sixth derivative plus x times dy over dx plus sine square x is equal to 0. Is this linear or non-linear? So let's look at this one. So this is first we check the coefficients, but what about this one? We said we want a and x, y, right? So there is no y. But look at that. Look at here the bx. Look at bx. So this we can think this one as a bx. So this is actually a linear one. So we can, for example, we can write this equation as minus sine square x. So this is our bx, right? So there is no problem with that. So this is a sixth order, and the coefficient only depends on x. So this is a sixth order linear differential equation. Great. Okay, this is linear. Okay, I will copy this one. Linear differential equation. Okay, I will paste it here. Oh, but I didn't copy, sorry. Great, so this is a linear differential equation. Okay, I will continue giving examples. So example 1, 2. Second example. Okay, let's keep going. So let's look at this one, d square y dx squared plus 5 sine y is equal to 0. So if you look at this example, so this is actually non-linear because of this sine y. So we can write this, even if we write this like this, sine y. So you see bx, so here bx, or we don't have anything, a single y, so this doesn't count as single y, right? So this is sine y, so it is a trigonometric function. We cannot not separate y from it. So this is a efendim? Ders kaydediyorum. Yok olsun. Birazdan geleyim yanına, olur mu? Bir bitsin. Sorry about that. There is a problem with my daughter. So okay, let's continue. Sorry about that. So this is sine y. What I mean is, so this is non-linear. Differential equation because of this sine y, so it doesn't fit anywhere. So this we cannot count it as bx because it doesn't depend only on x, so it depends on y. But we can still talk about the order. What is the order? Order is, it is a second order differential equation. So this is a second order nonlinear differential equation. We can still talk about the order. Let's keep giving example. For example, let's look at this one. 3x squared y prime plus 5 tangent x is equal to 0. So here we don't have a problem with bx, so this is bx, okay, but we have the problem here because if we think this one as the coefficient of the some derivative, so you see we look at the coefficients. Here we look at the coefficients. So they should depend only on x. So since the coefficient of y prime, since the coefficient of y prime 3x squared y, so does not depend only on x, right? So this doesn't depend only on x. So the y there is a problem. So this is because of this reason it is not it is a non-linear. It is not linear. It is non-linear. What is the order? It is first order ordinary differential equation. It is first order ordinary differential equation. Great. I think things are getting clear, but I will keep giving examples. I would like to. Okay, let's look at this one. 3x squared d5y dx5 plus e to the power x dy over dx plus x ln x is equal to 0. So there is no problem here, right? Let's look at the coefficients. So, and we can think this one as bx. Here you see we can write bx here, or we can write it as minus bx is equal to 0. Blah, blah, blah. Minus bx is equal to 0. So there is no problem with that. And the coefficients, all the coefficients depends only on x. So this is a linear. So this is linear. And what is the order? The order of the highest derivative. It is fifth order ordinary differential equation.